Hi, I am happy to participate in this important event. In this moment, I present my paper called Team Productivity in Agile Software Development, a Systematic Mapping Study. The authors are Giovanni Hernández Pantoja from Universidad Mariana, and my person, Sandra Marcela Guerrero Calvache from Universidad de Nariño in Colombia. Okay. I will focus in my presentation on 6 main sections: problem, motivation, methodology, results, conclusion, limitation, and future work. Okay, problem. Productivity is an economic measure created at the end of the 18th century. In software engineering, it begins to be a study in the late 1970s. The conception of productivity is associated as the ratio between the outputs, functions, set of code lines, characteristics, and the inputs, time and effort. But when we talk about agile software development, this perception changes. Therefore, we identify the next problem. How to evaluate the team productivity in agile software development? The symptoms identified are limited information about team productivity in agile software development. The perception of productivity changes according to the role. Teams generated data permanently without a unified view of productivity. The values and principles exposed in Agile Manifesto are abstract to measure team productivity. The information generated by team is expensive to be translated into decision. The causes identified are little clarity in the concept of team productivity in AHZ and how it can be measured. The values and principles are not worked as practice for measuring productivity. The resources and effort invested exceed the benefit generated by the decision made. And finally, productivity concept based on traditional software models. Next, our motivation is characterizing conception of team productivity in AHZ through a systematic mapping study. Methodology. To conduct a systematic mapping study on team productivity in AHZ, the present study is guided by the systematic, orderly, methodical, and replicable process proposed by Patterson. The stages considered in this process are detailed in this figure. And stage number 1, defining research question. The research questions selected for this systematic mapping study are: how many primary studies describe the concept of team productivity performance in AHZ? And number 2, what types of the study do the article found refer to? Number 3, where do primary studies come from? Number 4, what is the publication frequency of the studies that describe the concept of team productivity in AHZ? Number 5, in what contexts are found the conception of team productivity in AHZ? Number 6, what methods of agile software development are contemplated in primary studies? Number 7, how do primary studies define team productivity in AHZ? And number 8, how is team productivity measured at AHZ? Okay, defining search string. In this phase, we build a search string considering the previously defined scope and the research question. And the strings includes the chairs and boolean operators shown in this figure. And the bibliographic databases considered are IEEE Explore, ACIN Digital Library, Scopus, Compendex, WebScience, and Springerly. Number 3 stage is the classification scheme was based on the application of the inclusion and exclusion criteria and the defining filter to select the most relevant studies. The inclusion criteria were studies published between 2001 and 2021, complete studies published in Journal Conference of Congress with peer review, studies published in English, studies related to productivity in agile software development, and studies that are reported as primary studies. For the current research, it was decided to consider the study signed 2001 because from this day the agility trend started to develop due the consolidation of the Manifesto for Agile Software Development. The chosen selection strategy applying the inclusion and exclusion criteria, you can see in this table. Stage number 4 is search execution. In this phase, we use the search string. Also, we consider the publication date, the language, and the type of content. It's important to mention that in IEEE Explorer and ACM data library, it was not possible to filter by language because this functionality was not available. Moreover, in the case of Springer Lean, the discipline and subdiscipline were considered according to the type of content. For example, for studies like conference papers, the selected discipline was computer science and the subdisciplines was software engineering. While for the studies whose type was article, the selected discipline was computer science and the subdiscipline was software engineering, programming, and operating system. Next one, in this phase, the title, abstract, and keywords of each of the selected studies are read. It should be noted that in the case of keywords, related terms were considered, which varied according to the search engine. The next step was removing duplicate studies. Next, we read the introduction, results, and conclusion of the article. And finally, we read the full article. In this figure, you can see the results obtained by each search engine, applying each filter mentioned. Okay, quality evaluation. In this phase, we consider it a set of criteria shown in this table. For quality evaluation in the selected papers, the criteria were report quality, rigor, credibility, and relevance. To evaluate the quality of the articles, ICAI was established as follows: high 2 point, medium 1 point, and low 0 points. The relevance criterion were related to the evaluation given by all the research to the study. The number of citations it has was taken as follows: greater than or equal to 10 citation, high 2 point, between 1 and 9 citation, medium 1 point, and no citation, low 0 point. The papers with a score equal to or greater than 80% of the total possible points were finally chosen. Okay, results. In this figure, you can see the results obtained by search engine in each applied filter. Number one, the number of current studies was 8 articles. The titles of the selected articles we can be here. In the second question related to the types of the study, we then identify to 62.5% are studies presented at a conference or in a journal. And number three, the question, the primary studies come from 50% of investigation are from European continent, 25% from Asian continent, 12.5% from North America, and 12.5% from Oceania. And number four question, the publication frequency of the studies that describe the concept of productivity in ASD is between 2018 and 2021 with 67.5% of the articles. The next one, the context of team productivity conception in ASD. All the articles come from studies development in the field of the software industry. And number six question, the methods of agile software development that are contemplated in primary studies were Scrum, programming, and Kanban. Number seven question about concept of team productivity in ASD. Is an abstract concept. Its meaning is still being studied and it's under construction. For software organization, team productivity in ASD plays a fundamental role because they consider it as an indicator for improvement within this process. Team productivity is composed of a set of factors of distinct types that generate an impact within the team, the organization, and even the market. It also visualizes customer satisfaction through the functional and quality delivery of a software product according to their expectation and needs. Finally, number eight, question related how is team productivity measured at ASD. And this investigation identified in the selected studies 63 factors that influence the measure of team productivity in ASD, which were organized into these four categories: meaning, impact, flexibility, and high performance. Uh, the meaning category includes the factors that are related to the perception that the member of the development team that have about productivity, which can be seen from an individual approach or from a general perspective. And impact category, the factor that affect with the team and that generate a negative, positive, or even neutral influence on its behavior. Flexibility category. In this category are gathered the factors that affect the performance of team when it's subject to conditions that imply change, that it's adapt change. And finally, high performance factor related to the capability that consolidate the identity of team and contributed to achieving higher levels of performance. Conclusions. The systematic mapping study conducted in SIDS information source, IEEE Explore, ACN Digital Library, Scopus Compendium and Web of Science, and Sprinterlin allow with the identification of primary studies with 63 factors to measure team productivity in Agile software development. Based on the study's analysis, an approximation is made to the definition of team productivity in ASD. That is an abstract concept of great relevance from software organizations, and it functions as an indicator for what continuous improvement. In addition, team productivity in ASD has factors that generate an impact that allow the achievement of the objectives associated with customer satisfaction. The identified factors were classified into four categories, meaning, impact, flexibility, and high performance. And finally, limitation and future work. The main limitation on this study was the bibliographic source of the information, such as Wilet or Scientific were not considered. It could be interesting to replicate the research include this search engine. As future work, it is intended to the conceptualization of team productivity in AZ together with the factor for its measure established in this systematic mapping study, be contrasted with the appreciation obtained by the member of ASD teams. This will allow proposing a measuring process through the construction of a team productivity evaluation from this context. Thank you so much. Any question?